Hello everyone, my name is Sirjit K. I am from SNCSE and my seminar topic is Latency aware flow allocation in 5G NGFI network. Introduction. Internet connection has been a significant field in the modern world. There is an exponential increase in the use of network in daily life. One of the major problems that we are facing is latency in 5G network. In this work, we focus on the latency overflow allocation LFA problem in the NGFI network. The main goal is to push forward the NGFI based RANs, which is connected by convergent packet switching transport network. Then we formulate LFA optimization. Literature survey. First topic is soft isolated network slicing evaluation for 5G low latency service with real application microburst. 5G mobile communication service can create much more traffic than 4G because of their performance evaluation in bitrate, latency and capacity. Network slicing is a mean to assure that the communication qualities in 5G mobile communication network and it decreases the interface like packet losses or delay in parallel with higher resource usage efficiency. Advantages. Its main advantage is cost is low. Disadvantages. The main disadvantage is quality of service is low. And the second one is frontal network modeling and dimensioning meeting ultra low latency requirement for 5G, enabling the transport of frontal traffic in next generation cellular network, that is 5G. The cloud radio access zero architecture requires a redesign of the frontal network featuring high capacity and low latency. So the research community is focusing on internet-based packet switching network. We propose using the high queuing delay percentiles of the G bar 1 queuing model as the key metrics in frontal network dimensioning. It concludes that conventional 10G, 40G and 100G transporters can cope with the multiple legacy delay guarantees. Its main advantage is cost of production is low and accuracy is high. And the main disadvantages is time consumption is high. And the third one is low latency TDM PON for 5G XOL. As 5G network gain momentum towards commercial deployments, TDM PON can provide an efficient, cost-effective transport to carry radio signals. It carries signals from processing entities of the 5G radio access network, that is RAN. The front-door segment of the RAN, the low latency requirements are challenging to support with the existing TDM PON operation. Its main advantage is enable low latency traffic with bandwidth efficiency and it is time flexibility. Disadvantages are high complexity and cost is high. These are the comparison table of the given three literature surveys. Working principle, network scenario and main assumptions. The radio unit RU, distributed unit DU and centralized unit CU in downlink sends periodically every 66.6 nanoseconds burst of internet frames. It contains radio data of constant bitrate. Packet queuing effects in latency in a non-deterministic way. We make use of a latency model development based on the model present in the account for the worst queuing delay in the switches. Eventually, The on-well latency limit for FH and MH flows is assumed to be 100 Newton second and 1 millisecond respectively. This is the diagram for network scenario and main assumptions. Here there is a control unit and DU, MMTC, EMBB, EMBB, URLLC. And next one is topology of the given scenario. Next is latency aware flow allocations. The latency aware flow allocation problem in the NGFI network considered concern proper selection of DU nodes in which radio processing functions are performed. The transition resources transport network for routing of FH and MH flows between a set of RE nodes and DU nodes selected and the CU nodes. The given constraint on maximum flow latency and link capacities. This is the diagram. Here in table 1, assume basic length m is equal to 1 and capacity of the network links. Switch network has length of 1 and capacity of 100. RU switch has 0.2 to 0.5 length and capacity of 10. DU switch has a length of 0.2 and capacity 400. CU switch has a length of 10 and capacity of 400. And table 2, assume bitrate of FH and MH flows. FH uplink has a 2.5931, FH downlink has a 2.9636, MH uplink has 0.5557 and MH downlink has 0.5557. This is the table of comparison. Next is a minimum usage of links, that is lines, and number of active DUs bars, and NGFI network with basic m is equal to 1 and longer m is equal to 2 links. Conclusion. We have addressed the problem of latency aware flow allocation in packet-based frontal transport network. We have made use of an efficient LFA optimization algorithm. We have applied a worst-case latency model for estimating latency of traffic flows. Analysis of the NGFI network performance shows that average flow latency increases with number of RUs. This is the reference. Thank you. I am concluding my seminar.